All right, now let's talk about planar notions. So this is a plane. Think of it as a flat surface that continues on in all directions. You see, planes can contain points and lines and other shapes. Points D, E, and G, call them coplanar. Just like when we had points that were on the same line, you call them collinear. These are coplanar. Points D, E, F, and G are non-coplanar. You can imagine that D, E, and G all being on one plane. D, G, and F, here's another plane that contains those 3 points. And D, E, and F has a plane that contains them and so on, but there's no one plane that contains all those points. All right, D, E, D, F here, and F, E, sort of these 3 lines that create this triangle, those are also coplanar. You can see this triangle that I drew. Imagine that you have a plane just resting on that triangle. Now, DE and EG, these 2 lines, first of all, they are coplanar. And second of all, they also are called intersecting. Because you can, for example, have 2 lines that are parallel on the same plane. They'll be coplanar but not intersecting. These 2 lines intersect at this point E. All right, now GF and DE here. Here's DE, here is GF. Those 2 lines, they do not intersect. There's also no plane that will contain those 2 lines. See if you can do it with your fingers. Like imagine that one line's going this way and another line's kind of hovering above it, going in some other direction. They will never touch each other. They're called skew lines. They not only will they never touch each other, but they're not in any sense parallel because there's no plane that contains the 2 of them. All right, now what do you call it when, for example, these 3 lines here, any 2 lines, of course, can intersect in one point, but when you have more than 2 lines intersecting in one point, you can call those concurrent. They intersect here at point, I was pointing to the wrong one, D, E, E, G, and E, F. These 3 points intersect at that point E. All right, so they're concurrent because it's sort of unusual for those lines, more than 2 lines to intersect in one point. All right, so some things that we should have some intuition about with points, lines, and planes. There's exactly 1 line that contains any 2 distinct points. And if 2 points lie in a plane, then the line connecting them lies in that plane. That should make sense. Like if you have these 2 points, you can't have that the line like comes off of the plane or something. It wouldn't make sense in our world. And if 2 distinct planes intersect, their intersection is a line. And lastly, 3 points determine a plane. So that means that there's exactly 1 plane that contains any 3 distinct non-collinear points. All right, so some notions about being parallel. Let me go back a page for a second and take a look at these 2 lines, which are coplanar, and these 2 lines will never intersect each other. We call them parallel. They have the same slope, if you will. They go in the same direction. They never meet. You can also call lines and planes parallel to each other. So, for example, here's an example of a plane and a line which are parallel. And here is a plane and a line where the plane contains the line. Right? And here you have an example of a plane and a line where the line is going through or intersecting the plane. And notice sometimes we use Greek letters here when we talk about planes. This is the letter alpha. Up here, that's the letter beta. It's like A and B in our alphabet. All right, so